Alright, in this video we'll be doing a few guided practice, some sample problems for compound interest. We've got 4 problems we'll work through. First problem, determine the final amount of a $1,000 investment at 7% interest compounded annually for 10 years. So, because this is compounded interest, we'll use our compound interest formula. P is 1,000, because they told us originally $1,000 investment. The R, rate, 0.07, because we converted this 7% into a decimal. N is 1, because it's compounded annually, only once a year. And T is 10, because it's 10 years. Simply substitute everything into the formula, and we can type this straight into the calculator. Right now, A of T, so there's our T time 10. The principal is 1,000. The rate, 0.07, N, 1, and NT. So I'll just substitute this straight into the calculator. And let's see what we go. Put it over here. We've got to clear this. So 1,000 times, well, I can do this in my head. 0.07 divided by 1 is 0.07. And when you add 1, we get 1.07. And all of this is going to be raised to the 10th power. Answer, 1967.15. Again, the final amount is a dollar amount. So eventually we're going to round this to dollars and cents. $1,967.15 is what our ultimate answer will be. This is what the calculator gave us. Our final amount, $1,967.15. Next problem. Determine the final amount of a $650 investment at 2.25% interest compounded quarterly for 30 months. All right, again, compound interest formula. Here, P is $650 investment there. The rate is 0.0225 because I simply typed this straight into the calculator. To demonstrate, I took there's our mixed number button. Let's clear this. Mixed number says we got 2.25, 2 and 1/4, and it's a percent. There's our percent button. So second percent. Calculator does all the work for us. There's our decimal, 0.0225. We continue. N is 4 because it was quarterly, and T is going to be 2.5. They gave us 30 months. T has to be in years. 30 months is 2.5 years. So substitute everything into the formula. A of T, the time is 2.5 years. There's our principal. The rate, the number of times is 4, and NT, NT. So this is going straight into the calculator. So let's see, we've got, let's clear this, 650 times 1 plus, is that 0.0225, that's over 4, move it over, parentheses, all of this is raised to the 4 times 2.5. Bam, there we go. So it looks like it's going to be $687.50 eventually. There's a 687 what the calculator told us, so our amount is $687.50. Couple more. Number 3. Approximately how long would it take a $1,500 investment to grow to $15,000 in an account that pays 5.75% interest compounded daily? So again, compound interest formula. Here P is 1,500. The R is 0.0575. Again, was just typed into the calculator. The N, number of times, 365 because it's daily. And A of T, so they give us the amount we're going to have after time has passed, which is the 15,000. So let's substitute everything into the formula. There's our A of T, there's the 15,000. The original amount was 1,500. There's the rate, there's the number of times it's compounded, number and t. So in this case, we actually have an algebraic equation where we're trying to solve for t. So SADMAP tells us to start getting rid of what's furthest from the unknown, which is that 1500. So 1500 is being multiplied, so we'll divide 1500 on both sides. Left side, we get 10 is equal to what's left over. Again, to get the t by itself, we need to start dealing with what's furthest. Right here, you know what? Instead of trying to get rid of these three numbers independently, let's go ahead and just simplify this. So let's see what that equals. What is that? 1 plus 0.0575 over 365. It's going to be a crazy decimal. Yeah, that's crazy. So, but that's what we'll put. What's that? 0.0000157 some stuff. There we go. All right. So we're still trying to get t by itself. Still want to start getting rid of numbers. So right now, this red number here is a base. In previous lessons, to get rid of this base, we will have to log. So we'll log on both sides and eventually apply the product property. So when it comes time to simplify, hey, this left side, log 10, if you recall, log 10, that actually equals 1. So when we simplify, we'll get 1 equals that 365t, because it came out in front, log, and I just rounded over here. So, still trying to get t by itself, let's divide both sides by that log. Left side, 1 over that log 1.0002, still left with 365t. T is being multiplied, so we'll divide 365 on both sides. So this is what's going to go inside the calculator. Let's see what we get. Alrighty. Let's clear this. So we first got this fraction, but the numerator is another fraction, so I hit it a second time. So there we go. 1 over, what's that, log? Where we at? Log 1.0002, 1, 2, 3, 2. And let's bring it down to the 365. Alright, let's see what we get. 31.5454. And what are we trying to find here? It says approximately how long will it take? So it looks like 31.54-ish years. Alright, so let's see. It's our 31.545 is approximately t. So about 31.5 years is about how long it'll take. In future problems, you will be told what to round to. But you can kind of sort of see from this answer, it's a little over 31.5 years. All right, next problem. Number 4. Approximately how long would it take your money to double in an account that pays 6.4% interest compounded semi-annually? Well, we'll still start with the same formula, our compound interest formula, and let's see what they gave us. All right, P. The original amount, they didn't tell us. It just said your money. So what we'll do is we'll just come up with some random amount. Let's say you had $100. So P will be $100 for us. We'll keep going. The rate, 0.064, because all I did was take this, divide by 100, move the decimal 2 places to the left. There we go. The number of times was semi-annual. That's why it's 2. And A of t, we don't know. Well, actually, they don't tell us what the amount is after. All they tell us is our money doubles. Well, because we started with $100, that means if it doubles, it goes to 200. So again, these are just random amounts we chose. If we chose 50, this would be 100. If we chose 1,000, this would be 2,000. And you'll see something really interesting occur. So let's just substitute these values in. There's my AT, 200. The original principal was 100. There's our rate, a number of times, semi-annual, twice, 2 times t. So just like the previous problem, we're trying to get t by itself. Let's start removing numbers. Divide both sides by 100. We get 2. I'm going to do the same thing. I'm going to simplify what's inside here, see what we get. All right, we're doing 1 plus 0.064 over 2. See what that gives us. Well, that's not too bad. 1.032. Bam. All right. Time to get the base from the right side. So which means we'll log on both sides and apply the product property. The power property, sorry. So we're left with log 2. There's the 2t, which was the exponent. Log 1.032. To get the t by itself, we'll divide by this log. Divide log on both sides. We're left with the 2t. Divide by 2. So here we'll get, so we'll substitute into the calculator. Alrighty, let's clear this. There's our fraction. On top we've got, what's that, log 2 over log 1.032. 1.032. And this is all over 2. Enter. 11.0028 some stuff. And we want to know how long. So it's a little over just about 11 years. All right, so this is what the calculator told us. So it's about 11 years. Now, if you were wondering if we had chosen other amounts, let's just say the $100 was 30 bucks. Well, if that means we started with 30 bucks, that means we ended with 60, which means the 30 and the 60 would have gone there. So it would have been 60 over 30, which would have still been 2. So everything else would have been the exact same. So with this situation, no matter what amount you put here, as long as this is double the original amount. So now, you've got a couple practice problems for you to do. Only these 3 problems here. So you've got these independent practice problems, these 6 problems to complete.